Hi class, welcome to another session on biomaterials. So now that we have completed our first unit, let us go crack on with the second unit, which is metallic and ceramic materials. Now metals and ceramic, as we all know, have been widely used for making implants. So let us see what kind of metals and what kind of ceramics are actually used as biomaterials. So as an overview for this unit, we are going to study metallic implants. That is, the metals that we are going to study about are stainless steel, cobalt-based alloys, titanium-based alloys, shape memory alloys, nanostructured metal implants, degradation and corrosion associated with metallic implants. And in ceramic implants, we shall study about the biodegradable, bioinert, and biosorbable ceramics, bioactive ceramics, and nanostructured bioceramics. So this is about the second unit. So let us crack on with the metallic implants. So owing to their high metallic strength or high mechanical strength, these implants are widely used in areas where you require a lot of load bearing. So orthopedic load-bearing joints are one of the common examples of where metals are used. Other applications include manufacturing bone screws and bone plates, which are basically orthopedic load-bearing joint implants. Then you've got the casting of the casing of the pacemaker, the outer covering, the hermetically sealed covering of the pacemaker, which protects the electronics inside. Then you have the dental implants, stents, surgical clips and wires, as well as catheters. Now you might argue, where do we use metallic catheters? Well, in procedures like angioplasty and angiography, you have to use metallic catheters. So the commonly used metals for manufacturing these implants are stainless steel, cobalt chromium alloys, and titanium-based alloys. So let us start on with stainless steel alloys. And then we'll go on to discuss the cobalt chromium alloys and titanium-based alloys in another video. So stainless steel, as we all know, is an alloy of iron. It contains very low carbon and it contains around 17 to 20% of chromium. Yeah, I spelled chromium correct. I was just looking at the spelling. The presence of chromium in stainless steel improves its corrosion resistance due to the formation of chromium oxide. So chromium oxide is a protective layer that forms on the surface of the stainless steel, and this is non-corrosive. When the metal comes in contact with oxygen, the chromium oxidizes first, and then it protects the underlying steel and steel part of the alloy. So this alloy also contains small amount of molybdenum, which improves the pitting corrosion. We shall discuss different type of corrosion in a bit. And an alloy of iron that has that has carbon, chromium, and molybdenum in it is called the 316L. So it is stainless steel 316L. Now again, stainless steels can be of two types. It can be austenitic, that is face-centered cubic structure, or martensitic, which is body-centered cubic structure. So if you see the crystalline structures, so there are face-centered and body-centered structures. And I'm not going to go into details of that, but I'm sure you have studied about this in material science. So the the AISI, that is the American Iron and Steel Institute, has given certain series names for stainless steel that are austenitic in nature and that are martensitic in nature. So any name that starts in 300, the 300 series are austenitic, and any name of stainless steel that starts with the 400 series is martensitic. Right? So 316L is in the 300 series, and that's why it is austenitic stainless steel. Now the L in 316 indicates low carbon. Now you have to have low carbon in stainless steel in order to make it really, really rigid, in order to increase its strength, total overall strength. So if you for example take mild steel, then mild steel might be would have high carbon content. Therefore, it's very, very easy. So you can just use a file to make a job of your choice using mild steel. It's easy to cut. You can use a handsaw to cut mild steel as well. So carbon content of more than 0.03% can lead to the formation of carbides. So now formation of carbides results in sensitized steel, and which is weaker than the steel with really low carbon content. So 316L also has minor quantity of nickel along with silicon, manganese, sulfur and phosphorus. So nickel is added to stabilize the austenitic bonds in the stainless steel. So these get weakened with the ferrite bondings when chromium is introduced, and therefore to compensate for the weakening, nickel is added to it as well. It's just a complicated procedure. It sounds a bit like cooking, doesn't it? Like, you just add a little bit of salt. If it's too salty, you add a little bit of spice, and if it is too spicy, you add a little bit of jaggery or something like that. So this is similar to that. In order to have a really good product, you have to have certain metals which are high in quantity, certain metals which are low in quantity as well. But all these metals are added into an alloy for a specific purpose. Nickel is also added for a specific purpose, which is to stabilize the ferrite, which is to stabilize the austenitic bonds which get weakened due to the ferrite bonding. Now, ASTM, also called the American Society of Testing and Materials, has specified certain guidelines based on which 316L is categorized as a single-phase austenitic metals. So therefore, it should not have carbide and ferrite phases. If it does have, then that is not good quality steel, and it wouldn't, qualify as 316L. You can't sell it as 316L. So austenitic group of stainless steel are non-ferromagnetic in nature, and they cannot be hardened with heat therapy. Martensitic stainless steel, on the other hand, are ferromagnetic and they have high hardness. Therefore, these materials are used to manufacture dental and surgical implants such as the dental burrs, chisels, orthodontic pliers, etc. So, if you are manufacturing, these surgical instruments, you'd rather choose martensitic stainless steel over austenitic stainless steel. So, it depends on your application, what kind of stainless steel you're choosing. So you would just say like, oh, stainless steel is stainless steel. What difference does it make? Actually, it makes a lot of difference. You can't just randomly pick a particular stainless steel and try and make your implant out of it. Based on the wear and tear that a device is going to be subjected to, and based on the application, you have to use different types of stainless steel as well. Some stainless steels were nitrogen strengthened alloys such as the F1314, F1586 and F2229, and these nitrogen strengthened alloys have superior corrosion resistance and mechanical properties when compared to 316L. So, depending on the place of implant, depending on the type of implant, and depending upon the stress and strain experienced by the implant, you would either choose 316L, or you'd choose martensitic stainless steel, or you'd choose nitrogen strengthened alloys alloy based stainless steel. And it totally depends upon your application, like what application you're using for. I hope you had a very fruitful session learning about stainless steel with me. I shall see you again soon with another video. Thank you very much.